All right, so the last part we talked about was average velocity. So remember how I talked about going to Vegas? Let's say it's 200 miles away, it took you 4 hours. So you average 50 miles per hour. But we know, when COVID's not happening, the average speed on the 210 is probably closer to 10 miles per hour. So there's an issue. All right, so how fast are you actually going on the speedway between Barstow and Vegas? So if you look at your speedometer, it gives you the instantaneous velocity, how fast you're going at a specific point in time. So whenever you look at your speedometer, that is going to be your instantaneous velocity. It's at a certain instant. So at a certain instant means we're looking at the tangent. So this should be pretty familiar because this is what we went over on the first and second days of this lesson. So let's say we just want an instant in time, not the average, right? Just at this one instant, how fast is it going? Let's see. A window washer accidentally drops his lunch off a scaffold 1,400 feet above the ground. The position of the lunch in relation to the ground is given by this equation, where t is the time given in seconds and the position is given in feet. Find the instantaneous velocity of the lunch v of t at 7 seconds. Okay, so we're looking for the tangent, right? Because that's the instantaneous velocity. So we got to use this equation that's up here. So we want to know v of 7, because at 7 seconds, let's see what would be. So you take v of 7 plus h minus v of 7 all over h. So this is going to be, let's see, so we plug in the 7 plus h into the equation right here. Everywhere there's a t, you put a 7 plus h. All right, so I have 1,400 minus 16 times 7 plus h squared. And I'm going to be subtracting v of 7. So that I'm just going to be, let's see, 1,400 minus 16 times 7 squared. All over h. All right, and we are taking the limit as h approaches 0. All right, so I need to simplify this a little bit. Okay, so this is going to be the limit as h approaches 0. 1,400, let's see, so the 7 plus h squared, if I FOIL it out, it's going to be 49 plus 14h plus h squared. So let's go ahead and let's multiply each of those by negative 16. So let's see, we get, I'm just going to leave it as negative 16 times 49. Let's see, negative 16 times 14h and negative 16 times h squared. And I need to distribute this negative over here. So this is going to be minus 1,400, and then this is a plus 16 times 49, since 7 squared is 49, all over h. All right, so 16 times 49, negative 16 times 49, positive 1,400, negative 1,400, awesome. Let's come down here. As h approaches 0, let's just rewrite it. So I have negative 16h squared minus 16, let's see, times 14h all over h. I can cross out, since there's an h in every single term, I can cross it out. So I'll be left with the limit as h approaches 0 of negative 16h minus 16 times 14, so that's going to be negative 224. I guess I could have done that multiplication before. All right, and then as we direct substitute in 0 for h, you just get negative 224, and the units are going to be feet per second. Let's see, find the units. Feet, and time is in seconds, so feet per second. Negative 224 feet per second. So this makes sense because negative means going down, and this window washer dropped his lunch, so it's going down. So the velocity should be down because it's traveling downwards. So we know our sign is correct, and we went back and looked that our units match the problem. All right, the distance of feet, let's do the next example. The distance on feet What am I trying to say here? Oh, the distance of feet of a water rocket from the ground, t seconds, is given by this function right here. Find the expression for the instantaneous velocity at a rocket time t. Okay, so we want the expression, which means it's going to be in terms of t, because that's our variable. Okay, so let's find the expression instantaneous velocity. So we know the instantaneous velocity is going to be our limit equation. Okay, so limit as h approaches 0 of s of t plus h minus s of t all over h. So this is the same thing as part 2 that we've already gone over. Alright, so here we want to plug in t plus h into the function everywhere there was a t. So we're going step by step. Alright, so I have 90 times t plus h minus 16 times, we have t plus h and squared, which means you're going to have to FOIL it out. So that's the first part. And then we are subtracting s of t. So that's straight up just the function as given. And then this is all over h. All right, let's get to work. Let's distribute this out. Okay, so I'll do it right here. Limit as h approaches 0. All right, so I have 90t. All right, so I'm distributing this out. All right, so we're distributing this out. Let's continue on. So this is minus 16t squared. Little review, t plus h squared, FOIL it out. So you have t plus h times t plus h. T squared plus 2th plus h squared. So I'm going to distribute the negative 16. So I have negative 32th minus 16h squared, and then distribute the negative to both of these terms. So you have negative 90t plus 16t squared, and this is all over h. Alright, let's simplify a little bit. So I have negative 90t, positive 90t, negative 16t squared, positive 16t squared. Okay, rewrite. As h approaches 0. Alright, so I have 90h minus 32th minus 16h squared all over h. So it's your option if you want to rewrite it as factored, or as long as you're only canceling out one h per term, you're good. Rewrite, limit as h approaches 0. We have 90 minus 32t minus 16h, and when we insert h is equal to 0, we are left with 90 minus 32t. This is an expression, so we answered the question. We want an expression for the instantaneous velocity. And that's it. So notice that really the problem that we were doing here, we use part 1 and part 2 of our notes and just applying it for instantaneous velocity. Alright, so part 5 is going to be putting it all together. Notice that there are a little more questions. I think I assigned 7 for you. Not too bad. Check your lesson plan for when the due date is.